In my last video, I talked about how to shop and buy electrical cables for your home. Today, in part 4, we're going to cover how to use a multimeter, or how do I find the hot wire or supply cable. Let's get started. It's kind of important to know which cable is the supply wire. You know, the cable that provides power from the electrical panel. Looking here, you can see that this electrical box looks really complicated. There are tons of cables coming in and out and wires everywhere. Now, I already know that the supply cable is in here somewhere. We just need to figure out which one it is. In order to find that supply cable, we need to know some basics on using a multimeter. Yes, multimeters are complicated and expensive, $50 to $100, perhaps even more. Multimeters can be used for many things. That's why they're called multimeters, duh. For those of you that know how to use a multimeter, obviously you can skip this section. Now remember what I said in part 2. In North America, the black wire is the hot wire, and the white wire is the neutral or ground wire, and this unsheathed wire is the grounding wire. The black wire is where the electricity originates from the electrical panel, and it's returned to the panel via the white wire. That completes the circuit. If you haven't watched part 2, I encourage you to check it out. Looking at my box again, you can see all the wires are disconnected, meaning they are not attached with any connectors, like this or this. So it's safe to flip the circuit breaker to on and hunt for the supply cable. Here's my multimeter again. You'll notice there are two leads connected to my multimeter, a red lead and a black lead. The convention with multimeters is the red lead is the hot wire and the black lead is the neutral wire. Since we want to measure voltage, the red lead is connected to the voltage port and the black lead is connected to this common port or grounding port. Now you're probably wondering, why did you say earlier black indicates hot and now you're saying red indicates hot? Great question. Why is red the hot wire on multimeters? Why is black the hot wire for North American electrical cabling in our homes? Here's another question. Why in the UK is red the hot wire and black the neutral wire for electrical wiring in their homes? Maybe the multimeter was invented in the UK? Oh yes, indeed it was, by a British post office engineer about 100 years ago. You can read all about it on Wikipedia. Maybe that explains it. If someone else knows a better answer, tell us in the comments below. Oh, and by the way, before I start getting comments talking about the color changes to the UK wiring system in 2004, yes, you are right. I was referring to the old UK color scheme. One final point. Most times, in fact all times I think, the black lead should be connected to this common port. The red lead, however, on my multimeter, can be attached to one of these three ports. Notice what we're doing. We're building a circuit on our multimeter. I have this red lead and this black lead, and they converge inside my multimeter to give me a reading that appears here on my LCD. If I attach my red lead here, you'll notice that this port is protected with a 10 amp fuse. If I use this to test my 15 amp circuit and the load on that circuit is greater than 10 amps, I'm going to have a problem, right? What's going to happen? Say it with me. I'll blow my fuse. So that's not good. I don't want to pay to replace my fuse inside my multimeter. If I move my red lead here, this circuit is protected with a 400 milliamp fuse. 1000 milliamps equals 1 amp, right? That's even worse. I'll blow that fuse too. Nope. I need to use this port. The maximum I can test here is 750 volts AC on this circuit, or maybe 500 volts? I'm not sure. Either way, I'm only looking for 120 volts AC, which is what I expect to find in my home. We're good. Now, I need to configure the settings to detect what I'm looking for, without, frying anything. Your multimeter might look a little different, but the fundamental principles are the same for all multimeters. My multimeter has a power button. Let's press it. I have a dial in the center. To measure voltage, I have two options, measure AC or DC. All electrical power delivered to homes is AC. In North America, most of our circuits in our homes should be 120 volts AC, and some are 240 volts AC. In Europe and the UK, the standard circuit voltage is 230 volts AC. It's kind of good to know what you're looking for. For your country, you can check here. You see here on the right, a V indicates voltage. You see this tilde character? That indicates volts AC. When I switch to DC, the tilde character disappears. Your multimeter might display this information differently. There are some devices in our homes that use DC, and in all cases, the power is supplied as AC, then converted to DC by that device. Your computer, or laptop, or phone charger, or car, or solar panel, or battery, all take in AC power and convert that power to DC. Okay, back to AC. See how the numbers are jumping around? Multimeters, or meters, can be highly sensitive. That's the voltage being detected in the air by my meter. The decimal place is currently set here to the left. Also, in the top right corner, my meter indicates auto, meaning it will do its best job to interpret the value I'm looking for and present it appropriately. If I wanted to control the range of values my meter displays, I could push this range button and move the decimal place to the right. As I move the decimal place to the right, I'm making my meter less sensitive, which in this case means I can look for higher and higher voltages. Notice how it switches modes from auto, which has disappeared, to man or manual. I can keep pressing the range button and move the decimal place to the right. If I go too far, I switch to measuring millivolts. It takes 1000 millivolts to equal 1 volt. So in this range, my meter is most sensitive. If your meter starts to beep, that probably indicates the detected value is out of range. Your meter is too sensitive. Now, your meter might not work exactly like this one does, but it should be very similar. My multimeter is now ready. Okay, finally, how do we get a reading? I simply pick a cable in my wall and touch my red lead to the black wire and touch my black lead to the white wire for a single cable. What I'm doing is completing the circuit from the electrical panel through my multimeter and back to the electrical panel. Like I said earlier, you need the power to be on or you won't find anything. My multimeter will show me the voltage detected on that cable. If it's nothing, I should see 0. I'm looking for about 120 volts AC. When I find that, I've discovered my supply cable. Let's test. Is it this one? No. Is it this one? Nope. How about this one? Perfect, I found it. You might not get a reading of exactly 120 volts. There are lots of factors that could affect the exact amount of voltage delivered to an individual circuit. 1. If your home is in a high density area, from the point of view of the utility, meaning lots of customers and limited electrical infrastructure or whatever, your voltage could be lower than 120 volts. It could be, or 2, the time of day, maybe higher or lower voltage. 3, it could be the age of the equipment in your area or home. 4, the target voltage the utility tries to deliver. To save money or capacity, the utility might decide to lower the target voltage. Some people might experience this as a brownout. Their lights will dim. 5, the length of the circuit or cable run. Longer cable runs will result in voltage drop. For homes, the cable runs are considered small, so you shouldn't experience much voltage drop, unless you're running a cable between buildings or to a pool or something like that. 6, the weather, maybe, or if your utility is having a problem or outage or something. 7, I don't know, lots of stuff. If you're an electrician, please comment below and tell us some of the variables that can affect our home's line voltage. Generally speaking, we want to see something in the range of about 120 volts, plus or minus 10. If your voltage is in that range of 130 to 110 volts, I think you're good. If your number is like less than 100 or greater than 140, yep, you got a problem. You're more likely to find a lower number than a higher number, I think. You may also have a 240 volt circuit in your home, and that's usually for an electric dryer or an electric stove or maybe even an electric car. Obviously, if you're working on that circuit, you'll know to look for 240 volts. Bottom line, we found our hot wire or supply cable. Perfect.